are actually considering here, what these authors are actually considering here is solving some BVP via our iteration method and the concept of fixed point theory, which already we know is a very beautiful concept. You see, as Dr. Keke earlier said, one of the things we consider in solving our problem, and Mr. Maker is working in VIPs, and he has constructed, and there already existing several algorithms, in solving various problems. You see, this problem you are seeing on the board, on the screen, we are having a Picard method here and the man iteration method. So as Dr. Keke did say earlier, a new research direction could be considering an iteration method that is more efficient in terms of rate of convergence, in terms of complexity. As you can see here, the authors in this paper consider Picard, which was introduced in 2013 by Sivakan, which I think we use it for solving contraction mapping, if I'm not mistaken. So this method has attracted a lot of authors as a result of its combination with Picard and MAN as it is here. And the speed of convergence is actually very, very interesting. So I think these authors have considered this method because already the paper they are improving on is that of Ali, which was published in 2020. The likes of Ali used BVP of order 2, but in this paper, they are considering order 3. That is another research direction, and that is a contribution. Their contribution in this case is they have considered a higher order. So in solving this problem, or perhaps one of the ideas or our own research direction could be considering higher order BVP. For example, I have barely seen order 3 or order 4 using iteration method. Sorry, there is order 3 in the literature, but I have not seen order 4 and perhaps higher order 5 or whichever order. So there we could, even if we use this very iteration method as it is here, to consider order 4 is a very different and beautiful result entirely. So, and again, you see, as seen here, the authors are now considering order 3. So if we can incorporate order 4, even if it's with this can, the Picard can is something. And again, there is an iteration method which has been introduced. We have M iteration method, and Dr. Keke in 2019 introduced a very interesting method which has been cited by several authors, the Picard Ishikawa. So we can equally use that. I think Picard Ishikawa can compete favorably with this Picard green, can green, or I think it's being faster than it in terms of the rate of convergence. The only difference is in the case of Picard can, it has one parametric sequence as it is this arrow end here. This arrow end is single, and the case of Picard Ishikawa is there are two sequences there, but in most cases it doesn't affect any or change anything. I've seen most cases where the Picard the iteration method have even 4 sequences, then it still converges faster than those which have 1. So Akanemo pointed out something that there was no uniqueness and existent theorem. As Dr. Keke rightly pointed out, the authors have shown that they have shown existence already. Look at it exactly as shown in this. I think, what number is this? Okay, this is 26. As shown here, you now see T of U minus T of Z. They have shown that it's less than or equals to delta norm of U minus Z. And that we know that since this is defined to be less than 1, that is a contraction mark. So it's in Banach a contraction principle, as Dr. Keke did earlier. it has been a very beautiful, it's been a beautiful concept from this point because even those in applied mathematics are using it in obtaining the uniqueness and existence of the solution. So already in the Banach contraction mapping guarantees, or Banach commutation principle guarantees existence. So if the authors here have shown, now lest I forget, this problem was reduced to a form of integral operator. You see, before you talk about fixed points, there must be a mapping or an operator. So to apply the iteration method in obtaining the solution, as they have done here, there must be some sort of integral operator, which the author have tried to, I think I think an integral operator is defined here, as we can see here. So in this case now, one can easily say, okay, we can apply any iteration method that will guarantee the convergence, you know. Hello?
Oh, network cannot continue.
Okay, okay. So, yes, since here the author, there's no need to state the uniqueness and existence theorem again, because from what the authors have done here already, if even if the theorem was stated, it will have boiled down to proving that it's a contraction. That's all. So they have simply shown here that T of U, which is the integral operator they have defined, they have shown that it is actually a contraction map. So if it's a contraction map, we are relaxed that since it is a contraction, we have sure of the existence, we have sure of the uniqueness of the solution, and that gave them the impetus to find the convergence theorem here. Like one of the presentations I had last 2 weeks, somebody in numerical analysis was presenting an article. At the end of the day, I asked him, how do you determine the existence and the uniqueness of this problem? It became a very serious issue for the person. So with what this author have done here, the author has shown that the solution exists and it is unique. So as such, you can go ahead with showing that the iteration method he is considering converges strongly to the unique solution as here. So now I say, assuming that condition 24, which guarantees the contraction principle holds, which is 24, then the PN, I think Dr. Keke has said all this, so I wouldn't waste much time on this. So our interest in this article, or as done in this work, is just to use already existing iteration method to show that a converges to the unique solution what the author is trying to consider here. He has shown that already there's an existing method, but this iteration method can be applied. He didn't need to introduce a new iteration method, but there is nothing wrong with introducing a new iteration method. Like one of our articles that is under review, what we did was to introduce something, a different iteration method entirely. So which is another thing we've done. And again, having done that, we use it to solve a third order BVP. That is another contribution, you know, to a different direction here. So I think what we should derive from this paper, we've seen the basic concept here. Most of these things here are normal as done in several articles. I think what we should be looking at here is we could use already existing iteration method which are more efficient. For example, the M iteration method is a very simple but very fast iteration method. It can be considered for even if it's third order BVP. It will be better than what these authors have used. If we consider M iteration method here, is far better in terms of rate of convergence than this iteration method the authors here have considered. So even if you consider it and consider this same third order BVP they have considered, our article is a very new one, and the numerical result we are going to use, or whichever result we are going to use in our analysis, you will see that our iteration method will actually converge faster because the M iteration scheme is more efficient. Even if we consider the figure Ishikawa that was introduced by Dr. Kuki in 2019, we will still see that it is more efficient in terms of rate of convergence. So I think what the reviewer or people will tend to see, how better is this iteration method you are using than others. I think Dr. Keka has analyzed all this, and you can see that already I've not seen where this author compare the canned green iteration method with other iteration methods. So if that is considered, we place it side by side in the table and show that the iteration method we are considering converges faster. In fact, we can even go ahead and show analytically before showing numerically. It's another way of contribution. I think I have not seen, I don't know, I have not seen a work that has done given iteration method converges faster. I think if we use the concept of Berinde in 2004 to show analytically, then having used the concept of analytical way, we come numerically again and show. I think that is, again, will be a very good contribution. So from what these authors have done, I have not seen a side-by-side placement of different iteration methods showing that their own is better. So even if we can show that in our own table, it will be a very beautiful result and a very beautiful concept. So I don't want to take too much of our time. So that's just the little I have to say. Thank you all for listening.
Thank you very much, Mr. Ofen, for that presentation. Yes, I think we've done well for today, except if there's any other question or observation. Do we have any other? We should be running up by now.
I observe something. I want to ask Mr. Austin.
Okay.
Yeah, Austin, can one use inertial? Can one introduce inertial term to that method of solution? And also, can one also use S iteration method? You talked about M iteration. Because that iteration also is a combination of man and something method. So
Okay.
X iteration and inertia can also add something just to speed up the convergence rate of the algorithm.
Okay, thank you very much, Mr. Meka. You see, S iteration method is a very small boy compared to the M iteration method I mentioned earlier. The S iteration method was introduced in 2007 by Agawa et al. To improve the existing Man and Ishikawa iteration scheme. So when he they introduced it, there were a lot of improvements. In fact, this iteration scheme was introduced in 2016 by Ula, and they showed that it exists far better than many iteration schemes that were doing better than S iteration scheme. For example, the likes of the one Abbas introduced in 2014 was even far better than S. So talking about the inertial term, I think basically I'm yet to see an article that that has considered inertial term. You know, inertial term in VIPs is considered to speed up the rate of convergence. So I think if one can embed such concept in it, in fact, I think we will get a lot of recognition for that. So I think thank you for that observation and contribution. Maybe one could equally consider that. I have seen recently where these inertial terms are used for classical iteration methods like Ishikawa and the rest. So perhaps we could consider bringing in inertial term perhaps in a different article or in many. In fact, this area is a new one that people are looking into. So we can have a lot of results from here by even considering an initial term and see if it's going to work. So thank you very much.
Yeah, Prof, Prof, can you hear me?
Yes, loud and clear, I can hear you.
Yeah, like we normally do in our seminar series in FUTO, the essence of all these things is for us to get new idea, not just for the fun of having seminar. And from what he has explained, you have explained, Mr. Kanemo have explained, I'm very much interested in this.
Mr. Ofen, I think you like Akanimo very well.
So, from
Mr.
what
Emeka, I'm your friend now. You barely mentioned me. I hope all is well.
what you have explained, I'm interested in this line of research. As I've just recently completed now, I can start looking at all these boundary value problem. In fact, Prof, I'm suggesting if the next research, let it be a collaborative one in which we all learn and start developing something new, not just focusing on one area. I'm very much interested in this area. So maybe often we will talk about it. I don't know, with Prof's approval, so that we look at how these things can be modified and look better. And also, I know some other PhD students are here. Somebody like Genevieve, you can take up also interest in this area. Austin is also there. Austin Panley of FUTO. So these things are fascinating and I'm interested. So I thank you for your well elaborate explanations. God bless.
Thank you very much. Meanwhile, it's Mr. Emeka now, but I can assure you in the next few months or even weeks, his title will change. He has actually concluded his thesis, and in fact, he's gone for virtually all the procedures in UKZN. So in a matter of few weeks from now, we expect that his title will change to a doctor. And for all our PhD students, we believe we should work hard.
Congratulations, sir.
Like
Back.
Congratulations.
Like he said, next week, next Saturday's presentation will also be handled by Austin Ofen. We expect that Austin will be looking at his own work. He has done a lot of work here too. So possibly at the end of your presentation next week, we have already observed some problems that we can solve. So what you should do is to list as many problems as possible. Like Emeka was saying, we begin to distribute problems and say, oh yeah, Genevieve and this, solve this. And we should begin to have directions for each and every one of us from next week. I'm sure, Austin, you are listening to that.
Yes.
So please, you make such suggestions in your screen next week after your presentation, so that we can people can begin to work immediately. So once again, I want to thank everyone. I want to thank you, Mr. Austin, for your insightful presentation. And I want to thank all the participants, Mr. Emeka, Siri Ugwogo, and Genevieve. Before now, I saw Dr. Nse was with us, and even Dr. Araka was also with us. And so that's our presentation for this week. We share the screen. Sorry, we share the link for next week presentation later on. So once again, I want to thank everyone for the meeting. Thank you and God bless you.
Thank you very much.